When x is 2 on this graph, what is what? Now you go to the x-axis, find where 2 is, and then you go and see what. So in this case, when you go up to the respective point, y is about 2.25-ish. Limits can be thought of the same way. Now we have a graph like this, and we're trying to determine the limits at some points. But for that to happen, we must understand how to identify if a limit exists. Now, unlike a fixed point, a limit can exist at values where a y value does not exist, or even an x value. If there's no point at that specific location, a limit can still exist. So, let me explain what that means in a second. So, let's look at the limit as x approaches -6. To identify if a limit exists, we must look at these rules. The limit from the left and the limit from the right to -6 must exist, and they must be equal. So, in other words, we go here and we write as x approaches -6. When you're talking about from the left, which is like this, all the way to -6 over here, x equals -6. You're putting a minus sign, and then write f of x, and everything's the same. Then, let's determine this. So as we go from the left side all the way to -6, we can see that the graph is going up and up. We can assume this is infinity because the graph extends out of the page. So, we can write equals infinity. I know infinity is not a quantity, but still in this notation, we can still put it as an equals to infinity. Okay, now the right side. So, we go here. Oh, I forgot to make this x bigger. So it's basically the same thing. Now we're looking from the right side, so it's going to be the arrows are going to lead that way. That. We're going to -6 from the right side. So instead of putting a negative sign on top of the 6, you put a positive sign. Everything goes the same. And again, this is going to infinity. So, same thing. Now we have determined that the limits do exist from the left and the right. Next, we have to determine if they're equal. And infinity equals infinity, so yes, they're equal. They're going the same direction, so yes. Limit as x approaches -6. Sorry. X approaches -6. F of x does exist. Okay, now let's determine how to solve this. Well, there's nothing to determine. We already said since the left side is equal to the right side, we determined that the limit does exist. The limit as x approaches -6 will literally be what the left and right side equal, which is infinity, which equals limit as x approaches -6 from the left, which equals the limit. Sorry, as x approaches -6 from the right. Easy. Now let's take a look at these 2 points. Let's call this point A, and let's call this x equals -2. So, point A, or where x equals -9, you can see that there's no left side limit. Now, I talked about how both limits must exist, but that does not apply to this specific section. That is a more complicated topic we'll discuss later. In this section, since we only have a limit from the right, and the graph is technically ending here, we're okay to conclude this limit as x approaches -9 as 0. We just can conclude it from the right side. Now, let's look at another point of failure. Here. Technically, the limit here from the left exists. The limit from the right exists. From the left, this is still a function because this is an open circle. So from the left, you're going to x equals -2, but it's not this, the graph is not meeting. It's not the same y value from the right side. Since they're not equal, the limit does not exist. And that's the same for here. If you can see, again, you're going this way and you're going this way. There's a distance and y values are not the same. You are not looking whether there's a solid circle or open circle. Whichever circle the graph, the part you're looking at is connected to, that's where the limit of that specific section exists. Since they're not equal, that's it, they're not equal. Now we looked at a vertical asymptote going the same direction over here. That's why the limit exists. If you're looking at this side here, this section right here, here the limit does not exist for the same reason. From the left side, you're going up to infinity. From the right side, you're going down to -infinity. Infinity is not equal to -infinity. You're never taking absolute value. You're every time looking at direction. Direction is very important with limits. Now, let's start equations. With equations, it's just as simple as graphs, actually. Now, you see this notation, and the first thing you should be doing is plugging in whatever your x is approaching to, which is this number over here. So, there are 3 types of expressions you can get. One would be as simple as this one over here. One can be harder, like this one. Or it could be like this. There could be more, but these are some of the basic ones. So let's look at the top one. The top one is the simplest as it can get, is a standard equation with no fractions, whatever. So to do this, all you have to do, this is step 1, always. Always sub x with a. And a is whatever number x approaches to. So, we're going to solve this equation. Basically, you just put 3 in for x. So this would be 3 times 3 squared plus 4 times 3 plus 9. And this would equal 48. And that's your limit. Limit as x approaches 3 of 3x squared plus 4x plus 9 is 48. Now, everything's not that easy. Now look at this one, for example. This one has a different approach. Now, you start with the same step, but this one has a problem. Okay, if you put 3 squared on the top minus 6 times 3, 18, plus 9, this would add up to 0. Now, if you do that for the bottom, that would also add up to 0. 0 over 0. This does not immediately reject the limit, but what this says is that we cannot conclude anything. We cannot conclude. So what do we do here? The best approach is simplify. And what does that mean? It depends on scenario. Here you have to use your creativity. In most cases, when you're starting with basic equations, they start out with factoring. Again, we're going to look at expanding simplification later in later videos, but this one deals with factoring. And this is one of the most common simplification techniques. So, how can we factor this? So we can factor this as x plus 3 and x minus 3. And we can also factor the top with x minus 3 squared, x plus 3, x minus 3. Now, what did we do here? We found a way to cancel out one of the x minus 3's. And what this does is it tries to remove the discontinuity. Let's see if it works now. So this works usually when there's a hole or there's no point there, but the graph still travels in that direction. So we can determine the limit. So here it seems to be working. So we have x minus 3 and over x plus 3. Okay, now, since we have simplified it, now we can plug it in. So 3 minus 3 is 0. 3 plus 3 is 9. But anything over 0 is 0. As long as it's not 0. So the answer to this is 0. Again, it could be any number. But we cannot conclude just by plugging it or plugging 3 into this equation in the first step. So we had to do this whole simplification process. So for the third one, it's another type, and this one relates to graphs. It requires more thinking. So they're asking limit as x approaches to of f of x. And this is where the rule I told you about the limit of the left-hand side and limit of the right-hand side existing and matching to be there. Now, if you think about this, right, we're now dealing with 2. So let's look at 2 only. Where are the 2's? We have a 2 right here, we have a 2 right here. So we don't really care about this section of the graph yet. We'll come back to that later. So, on the left-hand side, which is less than 2, when x is less than 2, which indicates the left-hand side, you use this equation. So what you're basically trying to prove is that limit as x approaches 2 minus is equal to whatever's greater. So x is greater than 2 is over here. So limit as x approaches 2 plus, that would be 3. So now you have to see if this works. Okay, so now you do the same thing as step 1. Always sub with a. Always sub with a. So 2 here is a. This minus and plus don't mean anything except for notation. So limit as x approaches 2, so this would be 2 times 2, so because you plug in 2 here, 2 times 2 equals 4, which here, since we don't have an x, that would still be 3, and this is not true. So this means that the limit as x approaches 2 of f of x does not exist. Now, I told you about a scenario where the left side and the right side must exist. And I was talking about how pretty much in graphical scenarios, they usually do. In equations, sometimes they do not have to be. For example, if you're talking about, let's say, I don't know, let's pick -1. -1, there's no graph that's going through it. There's no single point that's fixed at it, no open circle either. So there's no limit, because there's no limit from approaching from left or the right here. So that's all we have for today. And this is the basics of what limits are. Now we'll also continue this chapter through an advanced video where we're going to talk about some limit tricks and complex limits, including more than one functions within. And we're going to explore that in graphical form as well as equation form. And we can also take a look at infinite limits. Thank you.